So we're going to find the limit as x approaches 0 from the right of x to the x minus 1 minus 1 over x divided by the natural log of x. Now first of all, when I look at this limit, I see a 1 over x in the numerator of a fraction, so we have a complex fraction, which is kind of annoying. So let's just start out by multiplying the top and the bottom by x. What we get is the limit as x approaches 0 from the right of x to the x minus 1 over x times the natural log of x. And now, what do we get on the top and the bottom here? Well, I've linked the videos in the description so you can check them out. The limit as x approaches 0 from the right of x to the x is actually 1. So this limit is going to be 1 minus 1 over the limit of x times the natural log of x. Again, check the description. That's going to be equal to 0. So 0 over 0, which means we have an indeterminate form. So we're going to have to do some more work to figure out what this answer is. Since we know it's 0 over 0, that means we can use L'Hopital's rule right away. So let's take the derivative on the top and bottom. We have the limit as x approaches 0 from the right. The derivative of x to the x, video in the description, that's going to give us x to the x times natural log of x plus 1. The derivative of 1 is 0, so we can ignore that. And then on the bottom, by the product rule here, the derivative of x is 1, so you have 1 times natural log of x, plus, and then we have x times the derivative of natural log of x is 1 over x. So we can rewrite this as the limit as x approaches 0 from the right of x to the x times natural log of x plus 1 over natural log of x, and then x times 1 over x is 1. So we see we have natural log of x plus 1 on the top and bottom. We can cancel those out. That just gives us the limit as x approaches 0 of x to the x, and this is just equal to 1. So taking this limit, reducing the complex fraction using L'Hopital's rule, simplifies down to just 1. So that is our answer.